we will study properties of rotation matrices further. Another topic. Here we are considering three reference frames. Reference frame A, reference frame B and reference frame C. But all the three coinciding with the origin. But for the sake of simplicity we have drawn separately. But consider that they are coinciding with the same point origin. Reference frame A coincide with the stationary reference frame. Reference frame B. Here reference frame A is this. This one is x-axis. This one, see here. This one is y-axis and this one is z-axis. This way orientation. X, Y, Z. This one is here x, y and z. So if you rotate this frame by 90 degree anti-clockwise from my side, this way, it becomes this. Now this is B frame, anti-clockwise. Imagine you are observing from my side, otherwise direction opposite, becomes opposite. So imagine you are observing from my side. Now this one is X, this one is Y, this one is Z. We have rotated around Y from anti-clockwise. So for this reference frame, rotation matrix is what? RZ90. So rotation matrix for B frame is RZ90. If we apply this 0, minus 1, 0, 1, 0, 0, 0, 0, 1. This is B frame. This one is C. So if we rotate this frame, B frame, this one is Z, this one is Y, this one is X. So if we rotate this frame around Y, from X to Z, around Y, so Y remains same, this one, this way, it becomes this frame. Observe this. This one is Y, this one is Z and this one is X axis. We have rotated from this X to Z from my side. So the angle is minus 90, X to Z. This one. This one for see further rotation. For this, we have rotation initially rotation this for this red one, blue one, and green one. This one. So initially rotated this way, and then after rotated this way. So we have to consider two rotations side by side. Body fixed rotation. So for rotation matrix C, if you want to represent this in terms of A, we have to use RZ90 into RY minus 90. RY minus 90. And if you multiply this, we get this vector 0, minus 1, 0, 0, 0, minus 1, 1, 0, 0. Now, RAC. This is reference from A and this one is reference from C. This one. So it is rotation matrix, orientation of C with respect to A. And it is this, these two are same. 0, minus 1, 0, 0, 0, minus 1, 1, 0, 0. And what is RCA? RCA. This one. For RCA, applying RY90. This one. Orientation of A with respect to C. So we have to apply RY90, RZ minus 90. We get RY90, we get this one 0, 0, 1, minus 1, 0, 0, 0, minus 1, 0. We have applied RY90 into RZ minus 90. We get this one. Now R equal to RAB. Orientation of B with respect to A. It is RZ90 or it is 0, minus 1, 0, 1, 0, 0, 0, 0, 1. And for RBC, with respect to orientation of C with respect to B. So we have rotated this X, Y, this one Z. This one is B frame and we want to make C frame rotated this way. x to z. So ry minus 90. So 0 0 minus 1 0 1 0 1 0 0. See here, we have obtained this, but RAC and RCA are transpose of each other. See, observe here. So RAC and RCA are transpose of each other. This one. Okay. For RCA, that is orientation of A with respect to C. Orientation of A with respect to C. So we are going reverse. This one is C frame. This one is Y. This one is Z. And this one is X. This is C frame. This one. And we want to make it reference frame A. So first rotating about Y Z to X. Z to X. It is R by 90 around Y. So R by 90. And then after, if we rotate about Z this way, so RZ minus 90, we get this frame. So applying R by 90, RZ minus 90, we get this. Now RAC and RC are transposed of each other. So it comes confirms that RAC and RC are transpose of each other. Okay. A simple calculation shows that RAC into RCA equal to I. That is RAC equal to RCA inverse. Or equivalently from proposition 3.3, RAC equal to transpose of RCA. We have studied already. In fact, for any two frames D and C, RDC equal to RCD inverse equal to RCD transpose. We have verified this from figure 3.7 here table. Changing the reference frame, RAB represents the orientation of B in A. Memorize the symbol. RAB stands for orientation of B in A. And RBC stands for represent orientation of C in B. A straightforward calculation shows that the orientation of C in A can be computed as RAC equal to RAB into RBC 3.22. In the previous equation, RBC can be viewed as a representation of the orientation of C, while RAB can be viewed as a mathematical operator that changes the reference frame from B to A. That is RAC equal to RAB into RBC. Change reference frame from B to A for this into RBC. A subscript cancellation rule helps us to remember this property. When multiplying two rotation matrices, if the second subscript of the first matrix matches the first subscript of the second matrix, the two subscripts cancel and a change of reference frame is achieved. That is RAB into RBC equal to RAB into RBC, BB cut out equal to RAC. So the symbol notation helps. The opposite symbol does not do much help. A rotation matrix is just a collection of three unit vectors. So the reference frame of a vector can also be changed by a rotation matrix using a modified version of the subscript cancellation rule. RAB into PB, BB cut out, so it is PA. So if we convert PB in reference frame A, this rule helps. RAB into PB, which cut out, so it is PA in reference frame A. Got it.